Okay, so just a reminder, we finished 26. That's the end of the material for the test on Thursday. We're doing 27 now, but to be clear, it is not, what we're about to do is not on Thursday's test. If we scroll just a little bit here, we will see that we've got 4 days left of, 4 lessons left of new stuff. 27, 28, 29, and 30. 27 is what we're doing today. 28, 29, 30 is next week. All 4 of these lessons, what word do you see in common? Algebraic fractions. That is what they have in common. So this last section of our course is all about algebraic fractions, whatever that means. I think I mentioned to you that I can't, what did I do? Did I mention to you that we canceled the quest a while ago? There was supposed to be one more quest. We canceled it. The last 2 homework assignments I'm not going to collect. I don't know if I mentioned that before, but 29 and 30 I'm just not going to collect. It's just we had too many snow days. Okay, so before we jump into the new stuff, the fractions, I just want to get one last little bit of review in here before Thursday's test. So that's why we're here on page 224. I'm going to highlight this equation. I'm going to say that's it's just a quadratic equation with 2 variables. And I'm going to tell you there's very few things that I can ask you to do on the test with things like that, with quadratic equations and 2 variables. But it is really easy for folks to get confused between how to handle the different things that I ask you to do. So on the one hand, I could give you an x and ask for a y. And I'm going to maybe put a little line through here and just change that c. Normally it's a y and an x, right? So I might give you an x and ask you for a y. On the other hand, I might give you a y and ask for an x, right? And then the last kind of thing I might do is ask for the vertex. 3 things. I'm going to show you specifically each of these 3 things for that example. But there's really only 3 things I can ask you to do. I suppose one other thing, let's add a 4th thing here. I might ask you to graph the parabola. All right, so maybe make a note there. We've got those 4 different kinds of things. The process for doing each of these kinds of things are really different. And we need to make sure that we do the right thing for the right problem. And I'll tell you that I haven't looked at your test number 2 in a long time. I wrote it in the fall semester, but I can say with pretty high confidence, I'm going to ask you to do these 4 things, not on one problem, but probably on different problems, and you just have to make sure you're doing the right process based on what I ask you for. So I might give you an x and ask you to find a y, but I'm not going to be as explicit as that. I'm not just going to say, hey, x is 2 and go find the y. I'm going to say something about the words. So let's take a look at the words here. The owners of a fruit orchard decide to produce gift baskets as a sideline. The cost per basket for producing x baskets is given by that formula. All right, let's just stop right there. X is the number of baskets, y is the cost, okay? Just going to put that up here. Number of baskets, y is the cost. It doesn't actually say here. I'm going to assume it's in dollars. Okay. So for this first problem right here, give you an x and ask you for a y. I might say something like, how much does it cost to make 10 baskets? How much does it cost to make 10 baskets? When I give you that number 10, am I giving you an x or am I giving you a y? One vote for y. Other votes. 10 baskets. Is that an x value or a y value? That is an x value because x is the number of baskets and 10 is the number of baskets. And when I say how much does it cost, am I asking you for an x or a y? I am asking you for a y. So as soon as we recognize that this thing in red is really just Ian's giving an x and asking for a y, it's easy. What do we do with that 10? We'll plug it into the equation for which letter? For x. You plug 10 in for x, and it's just arithmetic, and the output is the y, and the output is the cost, okay? We're not going to do it. It's easy. The hard part, the thing that we're reviewing right now, is how to recognize what process to do. Okay, next one. Suppose that we are here. I might say something like, the owners have, I'm running the show here. Let me do my thing. All right. Owners have $2,000 to spend. How many baskets can they make? Right? $2,000 to spend. How many baskets can they make? That $2,000, is that an X or a Y? That is the Y, that is the cost. When I ask how many baskets, am I asking for X or Y? I'm asking for X. So once we recognize that we are in this second case here, you say, oh, Ian's just giving me a Y and asking for an X. What do we do with that $2,000? Plug it into the equation for which? For the Y. It's really easy to plug it in for X. It's totally wrong to plug it in for X, but it's really easy. So we are plugging in for Y. In this case, I'm just going to write it. I'll erase it in a second here. But if you replace this with a 2,000, so imagine now we're trying to solve this equation. 2,000 equals 0.01 x squared minus 2x plus 120. This is a harder problem than this part A. Plugging in x equals 10 baskets is just arithmetic. You write it down, you type it on the calculator, you got your answer. This is much harder. This is algebra. What's the first step to solving that complicated equation? Get not the x on one side, but what number do I want on the left-hand side here? What's the magic number we want? It's a 0. We want that to be 0. Yeah? If it's a 0 equals, we've got tools for solving quadratic equations that say 0 equals. So the first step is subtract that 2,000. And once we've subtracted that 2,000, we're ready for, like box method factoring if you can, but as soon as I see that 0.01, I'm not even bothering. What am I using instead? Quadratic formula. It's just automatic for me. Subtract the 2,000, immediately quadratic formula. Still a big process. Definitely much harder than the first technique here, but that's the technique. And you can see how similar the red and black questions are and how different the techniques are. And I'm like really stressing this part of the test because I know that it's going to be really easy to pick the wrong option. Most important thing for these problems, like I trust that, like if I just gave you a Y and asked you for an X, or if I just gave you an X and asked you for a Y, most of us would get it right. It's really the translating, you know, from the words about gift baskets and money into, okay, what is Ian really, what kind of a problem is this really? Okay, so I think that is good there. All right, next one. I might ask you for a vertex, but I'm a really sneaky guy and I'm not just going to say find the vertex. I'm going to say something like find the number of write it over here. How many baskets to minimize the cost? And then what is the minimum cost? How many baskets to minimize the cost? And what is the minimum cost? Minimize is not even a thing. Minimize. Okay. What word in there says find the vertex? Minimum or minimize. This is a parabola. The 0.01 tells me this parabola opens which way? Up. It's a positive 0.01, which means that vertex is really at the bottom of the parabola. It is the minimum point. And so that is my tricky way of just saying find the vertex. And as soon as you recognize that, you're ready to just jump in and use our negative b over 2a vertex formula, right? When you do the negative b over 2a, you are finding x. It's always what the negative b over 2a finds, which is the number of baskets, which is the first part. Let's suppose that it's like 100 baskets is the minimum cost. How would you actually find the minimum cost? If you know it's 100 baskets, then it's going to get that minimum cost. Okay, you plug that in for X, right? Number of baskets is 100. You want to know the cost? Sure. Just plug in 100 for X, and it's one of these easy first kind of problems here. Okay. All right. So I think that's good. And then finally, graph the parabola. It's easy to recognize. I'm going to say graph the parabola, right? I'm not going to be, I can't be tricky on that one. I can be tricky on the first three questions. I've given you the kinds of format that I can be tricky with, but I can't be tricky with the graph the parabola. It'll just say graph the parabola, right? And I will walk you through the process. You don't need to have that thing memorized. You know, it'll say, does it open up or down Y? Find both coordinates of the Y-intercept, find both coordinates of the vertex. How many x-intercepts should it have? And if it has any, go find them, find the symmetric point, and then plot it. So like I'll walk you through that. But what I'm after here is translating these first three questions. Any questions about this? Don't know what to ask.
Maybe you asked any questions?
Yeah. So yes, all of them. All of the questions. That's what I have. Yeah. Okay, so you got still 2 days between now and then. I'm hoping that this has some meaning now, and if it doesn't have some meaning now, maybe as you study over the next 48 hours, it will have some more meaning. As you work through homework questions or as you work through the practice packet problems, keep these things in mind. You see one of these y equals x squared kind of things, I'm telling you, it's going to be one of these four. These are the only options, right? So you just have to decide. It's not going to be clear maybe which one of the four it is, but you translate what am I asking about with baskets and costs and which one of the four is it, and then do the process, okay? All right, let us move on. So we are here, page 228. Okay, so our daily summary. In this lesson, we begin our work with algebraic fractions, also called rational expressions. I think we'll use the first phrase more, including simplifying them, multiplying them, and dividing them. So there's a bunch of things you can do with fractions. 3 of them are right there: simplify, multiply, divide. The other 2 things we'll learn how to do are add and subtract. That's coming up next week. And then the last topic next week will be solving equations with these fractions in them. So number 1. Here are some examples of algebraic fractions: 5 over x squared, x over x plus 2, and then the last one there. So what makes these things algebraic fractions instead of just like regular fractions is that they have x's in them. You have a lot of experience with regular fractions involving only numbers, right? 3 over 17, 5 over negative 2. You got plenty of experience. You might not like the fractions with numbers in them, but you have lots of experience with them, and you know how to simplify them, and you know how to add and subtract them, and you know how to multiply and divide them. We're going to do all of that stuff that you already know how to do with normal fractions involving numbers. We're going to do it with fractions involving letters, okay? All right, so let's take a look at this example here. I'm going to write this thing out. I know it's just written over there. You can copy if you want, but you don't really need to. I'm going to simplify this thing. And typically what we're going to do as we learn how to do one of these new fraction techniques with x's involved is just remind ourselves, how did we do it when it was just numbers? And then let's apply the same techniques when there's x's. So 24 over 54. What number goes into both of these? What's the biggest number that goes into both? Like 2 definitely goes into both, but we can actually do even bigger than 2. 6 goes into both of these numbers. And so typically, I'm going to write something that I'm going to cross off. Typically, what we do is just this little shortcut. We just say, okay, 6 goes into this how many times? 4 times. And 6 goes into this how many times? Not quite 8. 9 times is good. So what's the answer, the reduced answer? 4 9ths. That's it. I'm going to get you 4 9ths. I'm going to get it in what appears to be a much more drawn out way, but it's going someplace good. So bear with me here. I'm going to rewrite 24 as being 6 times something, and I'm going to rewrite 54 as being 6 times something, because 6 is the biggest number that goes into both. So 24 is really 6 times 4, and 54 is 6 times 9 is good. And then I'm going to recognize that I have some technique about multiplying fractions. I'm going to write this, and you're going to tell me if you believe it to be true, that these 2 things are equal. How do you multiply fractions? You just go straight across, yes? Multiplying fractions is one of the easiest things to do with fractions because you just multiply straight across. So if you multiply straight across, you agree it's just 6 times 4 on the top and 6 times 9 on the bottom. Okay, and then finally, how much is 6 over 6? It is 1, and that's the whole point of all of this. is that 6 over 6 is just the fancy form of 1. And that's why 6 was important. And that 1 is why you can just cross off the 24 and 54 and put 4 and 9. It's because there's a 6 over a 6. And there's no need to write that because it doesn't have any impact. Okay, so there's 4/9. The right answer is drawn out, but we're going to use this technique for tougher problems here. All right, so this is the first appearance of something that we're going to call a fancy form of 1. 6 over 6 is a fancy form of 1. We're going to see lots of fancy forms of 1. But we're going to get tired of saying that expression, fancy form of 1, so we're just going to abbreviate the letters. We'll make an acronym, FFOO. Agree? Fancy form of 1. And then we're going to say FFOO, but it's kind of hard to say. So we're going to kind of make up an easy way to say it. Foo-foo is how we are going to say that. Foo-foo, foo-foo, like something. Foo-foo is how we're going to pronounce it. Okay, so let's take a look at number 4. Question is, can we cancel the 2's in these fractions? First one, 13 times 2 over 2 times 3. And the answer is yes. If you're not sure, I mean, we'll just do the arithmetic here. 13 times 2 is 26. 2 times 3 is 6. You can reduce a 2, and what do you get? 13 over 3, right? Which, so, oh yeah, okay, I guess we were allowed to reduce the 2's in that case. Let's take a look over here. The right answer is on top 15, and on the bottom 5. So definitely the right answer is 3. That's clear. But the question is, if we had said, oh, hey, there's a +2 and a +2, and I just canceled them, what do you get? You get 13 over 3. Is that the right answer? No. So apparently we did something we were not allowed to do. So you cannot cancel when there's what operation? Addition. We just discovered it. It's tempting. We just saw that it is wrong. But you can cancel when it's multiplication. Okay, I guess the next question is about subtraction. Let's just try. We'll get the right answer. What is it? 11 over -1. So that's -11. We're a little bit tired today. Fine. Okay, -11 is clearly the right answer. If I canceled the 2's, I get 13 minus, I'm not even really sure what to put up there. Is it a 0? Is it a 1? I don't know. But it's 13 on the top and maybe a 3 on the bottom, maybe a -3 on the bottom. It's definitely not the right answer, right? And so again, we have a conclusion. Can you cancel when there's subtraction? No. Can you cancel when there's addition? No. We can only cancel when there's multiplication. Now, there are going to be problems like this one right down here, where we say, hey, can you simplify this guy? And we're going to look for things to cancel. And so I will ask you, I see an x squared and an x squared. Can I cancel those x squareds? No, because they are near addition and or subtraction, and it's a no good. The only thing we can cancel is multiplication. So I cannot cancel those x squareds. I'm going to erase that in a second. How about these 9's? 9 and 9. Can I cancel them? No, for the same exact reason. So there are going to be lots of opportunities for you to cancel when you cannot cancel. And so I'm going to show you how to do this the right way, but maybe almost as important as knowing how to do it the right way is knowing to avoid the wrong ways. There's going to be so many temptations on these homework problems and on the final exam about these fraction questions to cancel when you cannot. And I've seen all too many times people will get like the right answer, they'll do everything the right way, and then they'll succumb to temptation and like cancel further when they should have stopped, right? The only time you can cancel is if it's multiplication on top and multiplication on the bottom. So apparently it's in our best interest to rewrite the top and the bottom so that it only involves multiplication and not addition and not subtraction. But we've got a process for turning things into multiplication, and that process is called factoring. And so I don't know how many of you guys like factoring from before. If you didn't like it before, you're probably not going to like it in the middle of these fraction problems, but here we are. So the good news for us is factoring is only 3 techniques for factoring these quadratics. I'll list them over here. First technique, always, always, always look for the greatest common factor. Second technique, not very common, but difference of 2 squares is something to look for. And then the third technique, if all else fails, maybe a 2x2 box, but that's the hardest process, so let's leave it for the last thing to attempt. Okay, let's look on top. X squared minus 9. What yeah, so first here, greatest common factor? Nothing to do. Is it a difference of two squares? Yes, it is. We just grab it. X plus 3, X minus 3. That is our difference of two squares formula. It should be about that quick for you guys. Okay, downstairs. We run through the same process, same order. Greatest common factor? Nothing to do there. I mean, the 6 and the 9 have a 3 in common, but the x squared doesn't have it, so we can't. Is it a difference of two squares? No, it's not even two terms. So all we're left with is a box, and in this case, yes, you're going to do the box. Now, I know that some of us do the box really quick, and some of us do the box a little bit slower, and some of us don't even do the box at all, but have shortcuts. Don't care how you get there. It's going to take you more time maybe than we're doing here, but I'm just going to put the answer and say there's maybe a big like 2-minute box process in between there. So do that. And then I will ask you, fundamentally, up on the top, is it an addition, is it a subtraction, or is it a multiplication? Fundamentally, is it addition? It is fundamentally multiplication. There's all three. There's addition, there's subtraction, there's multiplication. But at its heart, it is a multiplication. It is some big thing times some big thing. And if you go inside those big things, yes, there's addition and subtraction. But this is a multiplication. And that's what factoring is good for. So we ask ourselves, is there anything we can cancel? Well, coming back up here, you could cancel the 2's because there was an exact copy of the same thing on top and bottom. 2 and a 2. Is there an exact copy of the same thing on top and bottom? Yes. What is it? It is x plus 3. It is not 3. If you say 3, you are wrong. There is not an exact copy of 3 on top and bottom because there's no 3 being multiplied by everything. But there is an x plus 3 and an x plus 3. And so we just cancel x plus 3, x plus 3. And then we're going to write down what's left. Upstairs, I've got an x minus 3. I don't need the parentheses anymore. Downstairs, I have an x plus 3. And that is definitely simpler than the original version of that fraction. Okay, so let's finish this guy. I see x, I see x. I'm going to cancel those. So I got negative 3 over 3. And that simplifies to 1. Negative 1. Good? A little louder, Jeff. Nice and loud. This is a great question you're asking. Nice and loud.
Why can you cross those X's out now?
Jeff wants to know why I can cross off the X's. Jeff is questioning my authority, and with very good reason. Can I cross off those X's? The only time you can cancel is if it's multiplication. What's next to the X? Addition or subtraction. Can I cancel those X's? No, I cannot. But if you didn't have a big old question in your mind as to why was Ian allowed to do that, then you maybe are going to succumb to the temptation of going too far. This is what I talked about. It's so easy to get to the right answer and then go farther and make it a wrong answer. What's that? You do that with every problem. All right, here we go. We are back here. Can I cancel the X's? No, I cannot. Can I cancel the 3's? No, I cannot. We're done. X minus 3 over x plus 3, as far as we can go. That was a pretty mean trick, wasn't it? It's very stealth, yeah. Okay, next page. Okay, here's our next fraction. 3x plus 12 over 6x plus 24. 3x plus 12 over 6x plus 24. Okay, let's see. 3 and, let's start over here. 12 and 24. Can I do this? 12 goes into both, right? 1 and 2? You cannot do that. It's addition. Okay, so you caught me on that one. You guys are now watching more carefully what I'm doing here, but I'm going to get you on this one here. Look, that's a 3 times x. That's multiplication. That is a 6 times x. That's multiplication. And we said we can cancel when we have multiplication. Can I cancel those x's? Why not? It is still addition. Upstairs is an addition. Part of that addition is a 3 times x, but fundamentally that's a plus up on top. And I cannot go inside and ignore the plus. If it was just this, if it was just 3x over 6x, now we cancel, right? Now it's multiplication. But it is not multiplication here. We cannot cancel. What we need to do is factor. Don't jump to the box. First thing, always, 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 is the greatest common factor. What is the greatest common factor upstairs? 3. Go ahead and fill in those parentheses. Pull the 3 out. Fill in the parentheses. I think we get x plus 4. Is that all right? What is the greatest common factor downstairs? 6. Fill in the parentheses. Act surprised after you fill in the parentheses. What's in the parentheses? X plus 4. Hey, what do you know?
Canceling.
Now we can cancel. And the problems that you tackle, most of them are going to be very specifically chosen so that you get things that match perfectly top and bottom, and you can cancel. So we can cancel the x plus 4s, even though there's addition inside of there. Fundamentally, it is a multiplication. 3 times some stuff. 6 times the same stuff. That stuff cancels. So 3 over 6 is good, but we cancel here as well, right? 3 and 6 reduce. We get 1/2. That's our final answer. Okay, so why are we doing all this stuff with fractions anyway? Well, you know, I mean, scientists come up with fraction stuff all the time in applications. And if you had a choice between doing like some big long calculation where this 3x plus 12 over 6x plus 24 was inside of it, or doing the same big long calculation, but instead you had a half, which one would you rather work with? Half. And so scientists are really eager to cancel whenever they can. Makes things simpler. Okay, take a look at this next one. 2 plus x over 2. All right, what's the temptation? Cancel what? Cancel 2 and 2. Can we cancel the 2 and 2? We cannot. One of those 2's is ready to be canceled. It's the other one that's a problem. Which one of those 2's is ready to cancel? It's the one on the bottom. The one on the bottom has no addition or subtraction nearby, but the one on the top is not ready. So we factor. Greatest common factor on top. Can we do anything? Nope. Difference of 2 squares on top? Nope. Box method on top? It's not even an x squared, so no. So you cannot factor the top. 2 is just 2 on the bottom. You can't do anything there. And if you cannot do anything, then it's done. So I don't know what our standard acronym here, like cannot be simplified or something like that. Just done. Yeah. Just let me know that you recognize there's nothing to do. All of the tests will just be problems like that. All right, number 7. Okay, we're going to consider this fraction, x minus 3 over 3 minus x. There's a certain pattern we're going to look for, but let's establish that pattern first. Let's plug in x equals 10, top and bottom. So upstairs, 10 minus 3, downstairs, 3 minus the same x, 3 minus 10, okay? Upstairs, 7, downstairs is -7, right? And then the thing reduces to -1. Good? Okay, so when we plug in 10, we get -1. There's nothing particularly exciting about that. Let's plug in x equals -2, again, into the same fraction. So upstairs, it's a -2 minus 3. Downstairs is a 3 minus -2. Careful with your signs here. Upstairs, -5. Downstairs, 5. What does that simplify to? -1. And that's a little bit interesting that we plugged in 10 and we plugged in -2, and we ended up getting the same thing at the end. We got -1 both times. Now it's possible it's just a coincidence, but it turns out in this case it's not. You can plug any number you want to in for x, and you will get -1 at the end of the day. And so there's a particular pattern that we want to observe here, and the pattern is a number minus a number, and then downstairs is exactly the same thing, but what changed? It's just the order changed, just the opposite order. X minus 3 on top, 3 minus x on the bottom. Same thing, just swap. So I'm going to do this with my fingers a bunch when we're looking at for this pattern. Same thing, swap. It's also important as a subtraction. If it's addition, there is something to do, but it's different. X plus 3, 3 plus x. What is that equal to? Amy? It's 1, right? Because x plus 3 and 3 plus x are exactly the same, yes? Because addition doesn't matter what order you add things in. So if it's exactly the same with addition, then it's just 1. But our new pattern here is specifically about subtraction. Exactly the same, but subtracting in the different order. Okay, so here's the more general pattern right here. If you see a minus b over b minus a, that's the swapping. It is -1, and you replace with -1. And so here's an example done out. Starting with this original fraction, 64 minus x squared over x squared minus 6x minus 16. First step is to factor everything, because you cannot cancel anything yet. Upstairs is a difference of 2 squares. We see it? That 64 is kind of a giveaway. Hey, maybe that's a difference of 2 squares. One common mistake that I see people put here is they say, okay, difference of 2 squares, x, 8, 8 plus minus. That is no good. That is not equal to 64 minus x squared. What came first? 64. What needs to come first? 8s. You can't just put the x first every time. You have to be true to the order. And you can see if we FOIL here, you'll see what goes wrong. First times first is x squared, right? What's the last times last? Minus 64. The outers and inner will cancel. That's fine. But x squared minus 64 is not what we were trying to build. We were trying to build 64 minus x squared. So just be true to the order. This is no good. Okay, so 8 minus x, 8 plus x, that is correct. Factoring on the bottom is a box. Don't worry about how long it takes, but you get there. When you get there, x plus 2x minus 8 is what I get. And now take a look at those two circled things. 8 minus x, x minus 8. Do you see the pattern? Do you see the subtraction and then the same order but just swapped? Yeah? And so you get to change that whole thing to just a plain -1. So here's what it looks like in practice. You cancel them out. But if you just cancel them, you've made a mistake, because you can only cancel when things are equal. Those things are not equal. But when you cancel them, you simultaneously put a -1. You are crossing them off and replacing them with a -1, because after all, that's what the fraction is equal to, -1. Okay? And so then finally, the final answer is here. Typically, you just don't even write the 1. You just put a negative sign in the front of your fraction. Right? So that's really common. Looking for that pattern. Cross them off, put a negative in the front of the answer. Notice that this negative is in the front of the whole fraction. You're welcome to put it on top or on the bottom, not both. Safest thing is to put it in front of the whole thing. If you put it on top, so I'm going to write this, 8 plus x, x plus 2. If you say, hey, I know I'm supposed to put a negative sign, I'm just going to put it on top. It's okay to put it on top. But that negative sign on top is supposed to apply to the entire top. And right now, it's only touching what? The 8, and that is not the right answer. If you want to make it the right answer, you need to remember to put parentheses. This is correct now, but I just don't even bother. It's just one extra thing to potentially forget. So I just put it in the front of the whole fraction every time. No need to worry about extra parentheses. Okay, next. Let's take a look at this example right here. X plus 5, x minus 1, x minus 7, 1 plus x. Do you see the flippy thing here with the x and the 1? Can I cross them off and do the -1 thing? No, because? Yeah, they're supposed to be minus and minus. You can't do anything here. X minus 1 and 1 plus x. You just can't do anything. So just be careful. They have to be same thing, but reverse the order, but both subtraction. Okay, so that is all we're going to say about simplifying fractions. So what's left for us to do is multiply and divide. They're actually not hard. First, we'll remind ourselves of what to do with the division problem. I'm going to start here. This is already written out, but I'm going to put it again just so we can feel like we're doing stuff. Okay, copy it if you want, but otherwise it's written out there in front of you. So how do we divide two fractions? So this equals, you copy the first, We're going to change division to something friendlier for us. What is that change? It's multiplication. But then you have to pay for it. What happens to the second fraction? You flip it, right? So somewhere in your past, you saw this. And I don't know how it was presented. It might have been like in words like, keep the first, change the division to multiplication, flip the second, or like keep, change, flip, or some variation of that. But that's the process. And I think that you guys have seen that process at some point in your past. Okay, and I'll say that I'm going to write this, but don't copy this next part here. You are welcome to then just do the multiplication. How do we multiply fractions? Just straight across, yeah, straight across. 4 times 27, okay, that's not super simple. It's 108. Don't write this. Divided by 9 times 2, that's 18. But what do I still have to do here? This is correct, but not complete. We still have to reduce. It is not a simplified fraction. And that means you got to find numbers that go into both 108 and 18. All right, 2 goes into both. So I'm going to do this. I'm hoping you're not writing this. 54 over 9. There's still a number that goes into both. What is it? 3 goes into both. All right, now I got to figure out, okay, let's see. So I can do the bottom's easy, but 3 into 54, that's a little bit less easy. That's 18. And then finally, 18 over 3 is just 6. Okay, you'll get there. But let me show you a much better way. I'm going to put little things. I'm hoping you don't do stuff on the right side of that line. Much better is this. This is multiplication of fractions up here. You are welcome to reduce anything on top that has a partner on the bottom. That 4, what can it reduce with? The 2, 4 and the 2. 2 goes into both. This 2 becomes what number? 1, and the 4 becomes 2, yes? Some students have some concerns about like mixing and matching. It's like, oh, I took the numerator from one fraction, but the denominator from the other fraction. There are no concerns because we know when we multiply straight across, right? So even though it's 2 fractions right now, you could easily make it 1 fraction by just multiplying straight across. 4 times 27 over 9 times 2. There we go. It's 1 fraction. There's no problems about mixing and matching. Anything on the top with anything on the bottom. Let's keep going here. 27 and 9, what goes into both? 3 goes in, even bigger. 9 goes in, let's do that. 27, when we get the 9 out of there, is 3. 9 becomes 1, right? So it's easy now. Up on top, it's just a 2 times 3. What is that? 6. Downstairs, what times what? 1 times 1. So this is really just 6 over 1. Or 6. Clearly we get the right answer. The right answer was 6, but I am a big fan of reducing as early as possible, okay? All right, so same technique will work for us down in algebraic fraction land with x's and y's in some cases. Let's take a look at part A first. If you have concerns that they're not both fractions, you can fix that. This is really divided by 1, okay? So put it if it makes you feel better. This is a straight multiplication. We know that we multiply fractions straight across. But before we do, we're going to reduce anything we can. So take a look. X to the 9, x to the 4. X to the 9 over x to the 4. We have a shortcut for reducing. What do you do with those powers? How do they cancel? What do we do with them? What do we do with 9 and 4? You subtract them, right? And so it's just, there's a 1 left on the bottom, which normally we wouldn't write, right? So we subtract the powers when we have division with variables. So we're going to do that. We're just going to cross off. X to the 9th becomes x to the 5th. X to the 4th disappears completely. You can put a 1 down there if you want to. Okay, take a few moments, cancel as many y's as you can. Same technique. Make sure you put the remaining y's in the right spot, top or bottom. Okay, the y cubed on top, what happens to it? Completely disappears. Let's go here. How about the y to the 10? Y to the 7, right? Just subtracting the 10 minus 3. That's good. And we know they end up on the bottom because that's where more y's were. The y to the 10th wins out. Honestly, I think one of the toughest parts of these kinds of problems where there's lots of canceling is just making sure that you write things clearly enough that you can see what's still there. And so many times I've seen people, students that they just lose track of what's still there, or they miss something that they've written because it's kind of squished in there. So do what you can to write big. I have the advantage of lots of colors up here, but write big if you can. Okay, upstairs, I see a 15, I see a 2. I'm ready to multiply them. That's a 30. Oh, sorry. I did not cancel as much as I could have. What else cancels? Or reduces? The 15 and the 35. Let's do that too. 15 and 35, they both got a 5 inside. What's left on top? 3, and on the bottom, 7 is good. Okay, so now I'm ready for my final answer. Upstairs, all that's left is a 3, an x to the 5th, and a 2. I'm going to multiply the 3 and the 2 together. So that gives me a 6x to the 5. Over. Downstairs. 7 y to the 7. Good. Okay, so that's part A. Part B, same idea, it's just a little bit more work for us to do, but essentially it's the same. We're just trying to cancel wherever we can. Okay, first technique is to recognize this is not a multiplication, this is a division. So we're going to do our keep, change, flip idea from up above. So we're copying the first fraction in its entirety. That division symbol becomes multiplication. And then you pay for that change by doing what to the second fraction? Flipping it over. So carefully flip that second fraction over. Okay, I will say there is lots of temptation in this problem. Lots of things look cancelable. Nothing is cancelable. Right? I see 4 on top and bottom, no good. I see a 2 on the top and the bottom, no good. I see y squared on the top and the bottom, no good. There's a y on the top, there's a y on the bottom, no good. It's all addition, it's all subtraction. You cannot do anything until you turn it into multiplication. And the way you do that is to factor. So what's the next step? Equals. All right, we got 4 things to factor. We're going to do them quick. This first one here, greatest common factor. Nothing to do there. Difference of 2 squares is 4y squared. Is 4 a perfect square? Is y squared a perfect square? Is 1 a perfect square? What times what is 1? What times what is 1? 1 times 1 is 1. 1 is a perfect square. Might not think about it, but look here. 4 squared, 3 squared, 2 squared, 1 squared. Right? It's a perfect square. Difference of 2 squares is in play. What 2 things are going to give me 4y squared? 2y and 2y. What 2 things are going to give me a 1? 1 and 1. And then the pattern is a plus and a minus in either order. Plus 1, minus 1 is good. Right? It's easy to miss that. It's easy to forget that 1 is a perfect square. Okay, divide by. Now we're cleaning up the bottom left. Factoring. Greatest common factor? Yeah, 1. Nothing to do there. Difference of 2 squares? You bet it is. 2 minus y, 2 plus y. Any order is fine with that. Oh, I say any order. You could have put the plus first and the minus second. That's what I mean. But what you cannot do is the y first. You cannot do y plus 2, y minus 2. That is wrong. Times. Top right. It's easy to jump right to the box. You see a y squared, you might think box. That's not the first kind of factoring I want you to think. Greatest common factor, always first. What is it? It's a y, and that's great for us. So you take the y out, just write down what's left. Y minus 2. Okay, bottom, 4y plus 2. It's easy to miss that you can do something here. It's not a square. You might be tempted to just copy it. But greatest common factor we still look for. What is it? is 2. And then 2y plus 1 is what's left. Okay, so for those of us who enjoyed all the factoring we've just finished, this is good news for you. You get more of it. But if you weren't good at it before, you're going to get penalized for it again, unless you become good at it. Cannot do fraction stuff without doing factoring stuff. Okay, now everything is multiplication, so I am ready to cancel wherever I can. So there's no rhyme or reason here. You just look for things that are exactly the same. Exactly the same. I'm just going to go kind of in order here. 2y plus 1, does it have a partner? You bet. Cross it off. 2y plus 1, 2y plus 1. How about 2y minus 1? Does it have a partner? It does not. How about the y? Does it have a partner? You need a y sitting outside. You can't go inside. No, it does not. Y minus 2, does it have a partner? Not exactly, but almost. Y minus 2, 2 minus y. Do you see it? Y minus 2. Watch the finger. This is the best I can do. You see it? No, Nick, you weren't watching. Trevor, take a look. Y minus 2. That's it. That's our pattern, right? A minus B and B minus A both subtracting. You cancel them, but you pay for it, cross it off, and at the same time, big old negative sign. Put it right there in the front. Make it nice and big so you don't miss it. Okay, and then I think we're done. I went across the top, right? I checked every one of the factors on top. And there's still some stuff left over on top, and there's still some stuff on the bottom, but there's nothing else to look for. You don't have to look on the bottom because you've already checked everything on the top, so we're good. Now it's just a matter of writing our final answer. Here it goes. Big negative sign, don't forget it. Big fraction. What's on top? 2y minus 1. What else is on top? There's the y. Right now we're merging the two fractions together. Over, what's on the bottom? 2 plus y, and also 2. Avoid temptation. Do not cancel any of those 2's. Do not cancel any y's. Just stop. That one is done. You are welcome to distribute if you want to. You could distribute the y in on the top. You could distribute the 2 on the bottom. You never have to do that, and if you make a mistake in doing that, I have to take a point off. So honestly, it's better not to do that. You can if you want, but you are under no obligation to do so, okay? That answer is good. Questions on that? Okay, so to reiterate, there are 3 things that we did today. We simplified fractions, we multiplied fractions, and we divided fractions. So we're going to tackle part of this activity right here. Numbers 1 and 2 are just a tiny bit different from the stuff that we just did. I think it's good to be able to read through. We've only got 10 minutes, and I want us to do stuff that that looks kind of familiar to the demo. So can you jump to number 4 in the activity? I do want us to do 1, 2, and 3 at some point, and maybe at our next class, we've got a test coming up, but maybe Tuesday, if somebody can remind me, hey, Ian, we skipped those problems, I'll give you 10 minutes at the start of next class to do it. But let's just jump to number 4 right now and see what we can do.